All right, so to start, we have arithmetic and geometric, just regular sequences, okay? So these are your general forms, so you would plug in 20 for n if that was the case, okay? You have basic sigma notation, which is basically adding. So that sigma symbol, that E, means sum. And so basically, whatever the function is, you will plug in 1, 2, 3, 4, whatever number, all the way up to your top bound into that function and add them all up together. Okay? So say your function was like 2x, right? So it would be set up like this. Say it was like that, and you had I equals 1, and then up here you had 4. So that means that you will plug in 1, you will plug in 2, you will plug in 3, you will plug in 4, and then you will add all those up together. Okay? That's what sigma notation means. So whatever that function is, okay, whatever the lower bound is, you plug in those numbers all the way up to your upper bound and add them together. So then that will be 2 plus 4 plus 6 plus 8, which is 20. And that would be the sum of that particular sequence. Geometric notation. U sub n is still the same. That's still your nth term. U sub 1 is your first term. This time, R represents your common ratio. So that's the number that you're multiplying each term by to get the next. N still represents your number of terms. Okay? You guys remember this? Arithmetic series and geometric series. This is what you would do if you were trying to find the sum of a particular arithmetic sequence. Okay? You have two different formulas, but they're actually the same. You just use one over the other depending on the situation. So the first one, n over 2 times u1 plus un. N represents your number of terms. So you take half of that, u1 your first term, u sub n is your last term. So basically if they wanted you to find the sum of the first 20 terms, if you knew the 20th term and the first term, you could plug them in and use this. However, say you didn't have your 20th term, but you knew your first term and you could figure out your common difference. Well, then you would want to use this particular formula because all you need to know is your first term, your number of terms, and your common difference. Okay? Geometric series. Pretty straightforward. Your first term, your common ratio raised to your number of terms minus 1, all over your ratio minus 1. Please be careful with this one. Make sure that you put this in parentheses and you actually subtract 1 from your ratio before you ever divide the numerator by it. Or vice versa, you can do 1 minus the ratio, you still get the same answer. Now this bottom one, that is for infinite series, so ones that do not end. So they'll say, find the sum of this series. They might not tell you that there's 20 terms in there. So in that case, this is the formula that you use. R usually is less than 1 because that means that it is converging to a particular number. Do you guys remember converging and diverging? Yeah. Okay, converging basically means that as you're adding all these numbers in the sequence together, they're approaching one specific sum. And the reason why that's happening is because the numbers are basically getting smaller. And so you're basically adding a smaller number, so it's getting closer and closer and closer to one number. That means to converge. And that happens when your ratio is less than 1, whether it's positive or negative. That's why it's absolute value bars. Now, if the ratio is bigger than 1, say like it's 2, then the sequence is never going to converge to a particular number because it's just going to continue to get bigger and bigger and bigger. Okay? Prime example of that. Say you have the series 2, 8, 32, so on and so forth. And they wanted you to find the sum here. What's your ratio? 4. Because you're trying to figure out, okay, what number am I multiplying each time to get the next? So I multiply 2 by 4 to get 8, 8 by 4 to get 32, so on and so forth. And they want you to find the sum. Well, when you plug it in, your first term is 2. You'll have 1 minus 4 All right. Something's not right. Okay. This is probably a really, really bad example to use. Let me not make up one. Let me just use one that's in the notes, okay? But you'll see an example of, I believe every one of these used in the next, what's that, 14 slides? But these are your formulas for arithmetic and geometry, okay? So we're looking at examples from here on out. We're going to use those formulas. Now these are all going to go in your notes. All go in your notes. Okay? Here's the first one. All right. So first, is this arithmetic or geometric? So this arithmetic, what is the common difference?
0.6.
It is 0.6. We're adding 0.6 every time. Now this can be done without your calculator. I want to see no calculators out. I'll let you know when you have a calculator problem. This is simple enough though. Find the 15th term. Okay? So we're looking for u sub 15. To find any particular term, you're going to use that very first one, which is u1 plus n minus 1 times your common difference. Okay? This is used. You can either use this to find your first term, your number of terms, your common difference, a particular term. That very first equation is used for all of them. So we're basically going to have 14 times 0.6. Now you guys can do this without a calculator. What is 14.6? 8.4. So when you add these together, my 15th term is going to be 14. You guys right? Can I get some confirmation?
Yes.
Yes? Okay. As in, y'all did 14 times 0.6, that is 8.4? Okay. Now to find the expression for the nth term. So they're talking about just in general sense. So you have 5.6, your first term, plus n minus 1. We don't have anything to plug in for n because we're looking for a general term. Times your common difference, which is 0.6. Now, we can't leave it like this. We have to distribute. So we have 5.6 plus 0.6n minus 0.6. Can't leave it like that. Plus what? 0.6n. And this would be your expression to find any term in the sequence. Alright?
Oh, so you actually like do it out?
Mm-hmm. So you actually get all the way down to a simplified form. Alright? That's what it means to find the expression. Questions? Moving forward. Let's look at the next one. We're looking for the number of terms in the sequence. Where can I start? Which, is this arithmetic or geometric? If it's arithmetic, that means that I'm either adding or subtracting a number. What am I doing? Which number?
29.
So am I adding or subtracting that? So my common difference is a negative 29. Okay? So remember, common difference can either be positive or negative, but no matter what, we're going to add it. We're going to add it. So that's what making it negative means, that we'll end up actually subtracting it. So it's arithmetic. My common difference is negative 29. I know my first term and my last term, but I don't know exactly what term that is. So it's going to be u sub n. So I can use that same general formula to do exactly that. For u sub n, I'm going to plug in negative 156. U sub 1, I'm going to plug in 250. I don't know what it is, that's what I'm looking for. And then I'm going to plug in a negative 29. And then I'm going to solve for n. You guys go ahead and do that. 435?
Yeah.
So then you'll divide by negative 29, yes?
Yep.
And a good review of old school long division.
Yes.
How many times does 29 go into 43? Once. So then you multiply 9 into 20, 29 and 1. Then you subtract, what's 43 minus 29?
14.
You bring down your 5. How many times does 29 go into 145?
40. Wait.
5. Because then it ends up being a 5. Carry the 4. So 1. So this is negative 159. 156 is your 15th term. Questions? This one. Alright, for this one, the arithmetic sequence, use of 10 is 37 and use of 21 is 4. Find the common difference in the first term. You have two numbers in the sequence that are nowhere near each other. You know your 10th term is 37 and your 21st term is 4. So you remember how to do this. Yep, you can do that. You can temporarily make the 10th term the first term, which means that the 21st term would be is 11th to 12th.
12.
Because you're subtracting 9. We're going from the 10th term to the first term, so that's 9 spaces. So you gotta go 9 from 21. And then you can basically use that to help you find
Plug in like 21 equals first.
Plug in, you will,
No,
well,
that's yeah.
so we can use this information, okay? Our new 12th term is 4. Our first term is 37. Our common difference, we don't know, because we're trying to find. And n is going to be 12, okay? Because we had our 12th term. So we get an n set of another equation to get 37 plus 11d. Subtract 37 over, divide by 11, and d equals negative 3. Okay? To find our first term, how would I do that? Plug in which numbers? The new ones, the ones that y'all made up, the old ones. I can take any one of the old numbers, so the ones in green. So let's just take the 10th term to make it easier on myself. And I'm going to find my first term. I know my common difference is negative 3. So I'm using my 10th term, it's going to be 37 equals u sub 1 minus 3 times 10 minus 1. 10 minus 1 is 9. What's 9 times negative 3? So I have 37 equals u1 minus 27. Then I'll have to what? Add 27 to get my first term, which is using a little bit of thought about it. Okay, if my 10th term is 37 and my 21st term is smaller than that, my common difference has to have been negative, right? Has to be. Which means my first term has to be bigger than 37, which it is. Now, there's another way you can do this. I don't know if you guys remember. I showed you guys a different way, somewhat like a shortcut, right? You know your 21st term. You know your 10th term. So you subtract them. And you divide them by where they're placed in the sequence. And you get the same answer. So 4 minus 37 is? And what's 21 minus 10? There's your common difference. So it works both ways. And then of course you would do what you guys did at the bottom to find your first term. So this is just another way that you can find your common difference. And it works every time. You gotta make sure that the term and its place lines up. Okay? So if you put your 21st term first, you gotta make sure 21 is first. Alright?
So more difficult.
Easy peasy.
No, it would have to be the term on top. And then its place on the bottom. Oh, you mean like 37 go first? Yes, it would work. If you put 37 first, we just have to put 10 first, and this will subtract. Next one. Lots of examples today. Just kind of hitting all the bases. Here. And it tells you in the problem, find the common ratio. You should know automatically that this is what? Geometric. And then find the seventh term. And you can't tell off gate if this is what the ratio is. You can always take the second term and divide it by the first term. Or you can take your third term and divide it by the second term. No matter what, the ratio will be the same. Okay? What is 10 over 25 reduced down to be? What does 4 over 10 reduce down to be? So you'll get it whether you do the third with the second or the second with the first. If they ever ask you to show that something is geometric, this is what you would do. This is how you show it's geometric. You take every term and divide it. You wouldn't just do the second with the first. You have to do every single term they give you in the sequence to show that something's geometric. Okay? So our common ratio is 2/5, and I use that to find my seventh term. So u sub 7 equals my first term, so 25, times my ratio, raised to the n minus 1. So we got to the 6th power. Let's do calculators with this one. What you guys get? 64 over what? 625. So that is our seventh term. So I'm multiplying 2/5 to the previous term, and by the seventh term, I'm at 64 over 625.
5 to the 6. 5 to the 6.
5 to the 6 is 25 times 25 times 25.
I have no idea.
It's 25 times 25 times 25.
Yeah,
I got 15,625.
we're not doing 25,
5 to the
6,
6th.
you're doing
You
2/5
can
to the
Yeah,
6.
2 over 5.
Yeah, so it's 2 to the 6, which is
64.
64, and then
5
5
to
to
the
the 6 is 16, 625.
15, 6.
So then you're gonna multiply that by 25 on the outside, and 25 goes into 15,
Oh, okay, I didn't.
625.
Okay,
That
that
reduces
makes
down.
sense. I was like, why?
Okay. Here's one that's similar to that last one of arithmetic that we did. This is a geometric sequence, has second term of 50 and a fifth term of 3.2. Find the first term and the common ratio. What do you think we can do here?
Second term. We'll do the same thing with changing the u to 1, but this time we use divide.
Uh,
No. No, that's the
So,
same.
Joaquin's saying do the same thing that we did before. Make the second term our first term, which means this 3.2 would turn into our, what term? Fourth term. So I'll use the same setup as before.
Ratios.
And what's gonna go in for u sub n? 3.2. 50 is gonna be my first term, just temporarily. What's 4? I mean, what's R? What's R? Oh, R's R, sorry. Okay, that's what you were saying. Okay. And N is,
Three.
well, N is actually
4 minus
4 minus 1, which is 3. Okay?
Ms. Anderson, what's that, you want U2 equals 50 there?
This is from the original problem.
Oh, okay.
So this is from the original problem, and we're temporarily just making the 50 our first term, and the
Okay.
3.2 our fourth term.
Sorry, I just didn't have a problem. I wrote it down, but I didn't read it.
How do I solve for R?
Divide by 50.
This would be calculator. What's 3.2 divided by 50?
0.0.
Is that rounded or is that,
No, that's
8 over
that's-
125.
okay? 8 over 125?
Yeah.
So then how would I find R? What do I have to do? And if you think about it, what's the cube root of 8? 2. And what's the cube root of 125? So our ratio is, yes again, 2/5.
So,
No, not everything's 2/5. You can't do the cube root in your calculator. Where do you go? Go to math, and you'll see it as option, I think, 4. If you had to do a higher root, like a 7th root, you have to go to option 5, but you first have to type 7 into your home screen and then go to math 5 to get the 7th root.
You can always replace it too.
We could always do the power of what?
Or you can always do to the power 1/3. Don't forget about that feature. You can raise the fraction to the reciprocal, and that gets rid of it as well. To find our first term, it's the last thing that we do today. You go back, you use one of the original terms, such as the second term. You're looking for your first. You know your ratio is 2/5. N is 2. So you have 50 equals 2/5 U1. And when you multiply and divide, equals your first term. Alright? You guys do have homework. We didn't get a chance to get to the series, but there are some series questions on your homework. So use the formulas. I mean, it's pretty straightforward. We're just doing examples to refresh your memory. I think the homework tonight will refresh your memory as well.